You know that feeling, right? You ask your voice assistant something and it's like magic, but then you ask a slightly different question and it just completely whiffs. It hears the words, sure, but it doesn't really get what you mean. Well, that little gap, that frustrating space between just hearing and truly understanding, that's exactly what the next generation of AI is setting out to fix. All right, so here's our game plan for this explainer. We're going to look at how these new speech large language models are a total game changer. First, we'll talk about what it really means to listen. Then, we'll see how the tech has evolved, put these new AIs through their paces, uncover a couple of major hurdles they're still facing, and finally, peek into the future of how we'll talk to our tech. So let's start with the big idea here. What does it actually mean for a machine to understand us? Because it's so much more than just turning our speech into text. It's about getting all the meaning that's woven into the sound of our voice itself.
That word right there, effective, that's the whole ballgame. This isn't just about getting the words right. It's about having a real conversation, a real back and forth. The goal is to move past just barking commands and into a more natural, kind of intuitive partnership with our devices. This definition really nails it. True speech understanding is this whole integrated process. It's not just about the what, the words. It's about the how, was it said sarcastically? The who, is that my voice or someone else's? And even the where, what's going on in the background? That's the difference between a flat file transcript and a rich, real-world interpretation.
Yeah, think about it like this. Our voice is just packed with information on 3 different levels. You've got the linguistic level, the actual words we're saying. Then you've got the paralinguistic. That's the emotion, the tone, whether we sound excited or bored. And finally, the non-linguistic stuff. Is a car alarm going off outside? A truly smart AI has to juggle all of that at the same time. Okay, so getting to that kind of holistic understanding, well, it required a complete teardown of how these things were built. The old way of doing things just couldn't keep up. We've seen a massive change in just the last couple of years. For decades, speech systems were basically built like a factory assembly line. You had all these different modules, each doing one little job, but it was slow and clunky. More recently, things have shifted to these end-to-end systems, which means one single unified model handles everything, from the raw sound wave to the final output. Kind of like how our own brains work.
The old way, that cascaded pipeline, it was like a game of telephone. You know the one. Each step on the line would introduce a new little error, and by the end, the message was all garbled. And worse, all those crucial clues, like your tone of voice, they got lost in the very first step. The new unified way processes everything at once, so all that rich, important context is preserved from beginning to end.
So this is the really big takeaway. This huge shift in architecture from a clunky pipeline to an integrated brain is what makes this deeper understanding possible. We're moving from systems that just process sentences to ones that can interpret entire situations.
Okay, so we know these new models are a big deal, but how do they actually pull it off? Let's pop the hood for a second and see how they work.
It pretty much boils down to a 3-step dance. First, the system takes the raw sound and digitizes it, capturing every little detail. Second, and this is where the real magic happens, it fuses that audio data with the massive knowledge of a large language model. It's basically teaching the AI to connect sounds to ideas. And finally, the LLM uses that combined understanding to come up with a really smart response.
That all sounds great on paper, but how do these new models actually perform in the wild? I mean, can a jack of all trades really go toe-to-toe with a master of one?
Well, the answer is kind of surprising. Yes, absolutely. The research is showing that these generalist models are not only keeping up with the specialized ones, but in some cases, they're actually beating them at their own game.
Just take a look at this data. This is for automatic speech recognition, which is basically transcription. And here, a lower error rate is better. The Speech LLM actually makes fewer mistakes than a model that was built just for this one specific task. That's a huge deal.
Now, for something that goes beyond words, like trying to recognize emotion from a voice, the specialized model still has an edge. But look how competitive the Speech LLM is. It shows these things can handle really nuanced tasks, but it also tells us there's definitely still room for improvement.
But hey, despite all this incredible progress, it's not a done deal. Researchers have identified 2 major hurdles that these models still need to clear before they can become truly reliable for all of us. So here's challenge number 1. Think about how many different ways you can ask for the weather forecast. You know that "what's it like outside" and "will I need a jacket today" basically mean the same thing, but for these new AIs, it's not always that simple.
Researchers have a name for this: instruction sensitivity. It means the AI's performance can totally change just because you phrased your question a little differently. And that kind of unpredictability, that's a huge roadblock if you're trying to build something people can depend on.
The second hurdle is a little more mind-bending. It kind of hints at a weird trade-off that might be happening inside the AI's brain.
This data tells a fascinating story. Researchers took a base text-only AI and compared it to its sibling that was also trained on speech. And the result? The speech-enabled model was actually worse at understanding the user's intent. They call it semantic degradation, and it points to this really worrying idea. Maybe, in teaching the AI to be a better listener, we're accidentally making it a slightly worse thinker.
So we've seen these amazing breakthroughs and these really significant hurdles. Where does that leave us? What does the future of listening actually look like?
The big picture is that we're right in the middle of a massive shift. We're moving away from AI that just acts like a glorified dictation machine and toward AI that can be a truly perceptive partner in conversation, one that gets not just the words, but the real meaning behind them.
And that leaves us with a pretty deep question for the future. As these systems get better at understanding the full range of how we communicate, our sighs, our sarcasm, our excitement, our relationship with them is going to change. So as we build machines that can finally truly listen, we really have to start asking ourselves, what are we going to tell them?